So the mid-segment of a triangle is a segment that connects the midpoints of two sides of the triangle. The mid-segment of a triangle is a segment that connects the midpoints of two sides of a triangle. You're welcome. So because every triangle has three sides, it will have three mid-segments. And those three mid-segments are going to form something called a mid-segment triangle. Okay. Find midpoints, connect them, you've got a mid-segment. Find more midpoints, connect them, another mid-segment. Find one more, or connect the other two midpoints, you've got a third mid-segment, and that triangle formed is the mid-segment triangle. What questions do you have about this? All right, so let's see how this works. So this next triangle that I have, you don't have on your sheet. I just want you to watch. I've actually oriented it so that it would be easier to see, okay, at first glance. So what do you notice about the slopes of segment DE and segment AC? What kind of slope do those two have? Is it 0 or undefined? Okay, is it lots of rise and no run, or is it 0 rise and lots of run? 0 rise. So 0 over any number is 0. 0, right? When you said 0. Okay. DE has a slope of 0. AC has a slope of 0. They're both horizontal lines. Okay. What do we notice about the lengths of DE, segment DE, and segment AC? How long is segment DE? How long is segment AC? 0, 1 to 8, 1. Total of double, yep, double, total of 8. Okay, so let's see if that holds true for one that's not so nicely positioned. Okay, on your sheet now, we want to figure out if DE is a mid-segment. First of all, what's the slope of DE? And we want to see if it's the same as the slope of AC. Okay, so left half of the room from Mary on over, okay, Mary and Aubriana on over, I want you to find the slope of DE. And from the other side of the room, the right half of the room, I want you to find the slope of AC. Okay, on your sheet, count it out. How much are we rising? How much are we running? Okay, we have a prediction that it's the same. Okay, Matthew, how much did DE rise and run? What's the slope? How much did we go up? And how much do we run? So up 3 over 2, positive 3 halves for its slope, right? Okay, we went up 3 and over 2. Okay, and this side of the room, Sadie, what was the slope of AC? So up 6 over 4, which reduces to 3 over 2. Okay, so what do we know about lines that have the same slope? They're parallel. Very good. Okay, so the mid-segment will be parallel to the side that's opposite it. Okay, what do we notice about the lengths of DE, segment DE and segment AC? So this half of the room, I want you to find the length of segment DE. This half of the room, I want you to find the length of segment AC. So how do we find the length of a segment? Absolutely, distance formula. What's the distance formula? Okay, almost perfect. We have to minus in the middle. When we're adding, we're finding midpoint. When we're subtracting our coordinates, we're finding slope or distance. Okay? So this side of the room, find the distance between D and E. Other side of the room, find the distance between A and C. All right, Chris, what did you get for the distance between D and E? Give it to me in square root form if you want. And here's a hint. You can use your slope. Since we found our rise and our run, this is the change in y, the y2 minus y1. So we have a rise of 3, and the x2 minus x1 is 2. So what's 3 squared? And what's 2 squared? All right, so we're going to take the 9 plus 4 under our radical, and 9 plus 4 is 13. So someone tell me, what's the square root of 13? 3 point something, right? It's got to be less than square root of 16, which is 4. 3.6. You're very close, Josh. Good job. Okay. All right, now let's figure out from the other side of the room, what was the square root that you found for this distance? Sadie's got an answer, but I want to pick on somebody else. Got an answer for me? 52, square root of 52. Okay, what's square root of 52 as a radical, or as a decimal? 7.2. All right, did our prediction hold from the previous one? Do they have the same slope? And do they have, is the mid-segment half of the whole of the other segment? Very good. Okay, so that's our theorem. We can make millions and millions of triangles with millions and millions of mid-segments, and they're always going to be parallel to one side and half of its length. Okay? So you'll have a problem or two or three like this on your assignment today. So you've got a picture that looks like this. Add the x minus 7 and the 6x plus 18 to it. And they're going to ask you for something like the distance between D and E. Okay? So suggestions on how we would set that up. Jaden. Okay, so we want to see if we can just set them equal to each other, like we've been doing, bless you, most of the chapter, right? Because when we had angle bisectors, they were equidistant from the sides, and when we had perpendicular bisectors, that made those equidistant from the angles, so we could just say equals, right? But is this going to work this time? Why not? Very good. So you have two choices here, right? You can double DE, or you can half AC. Which one's easier? Either way, you decide, whichever one makes sense to you, right? As long as these are both even, you could divide each one by 2, right? And say 3x plus 9 equals x minus 7. That's one option. Because they're not equal right now, right? Or someone else may say, I like that 6x plus 18. I want to double the x minus 7. Make sense? Okay. So which way did you like better? Having it, because it's less easier numbers to work with maybe? Okay. You have to use distributive property here, right? Make sure you double both of those terms. All right, so let's work with the left side. we're going to do what to solve for x? Yep, subtract x, get the x's to one side. And in the same step, we're going to subtract 9. It was positive on this side, we'll take it away. So we'll get a negative, what, 16? So we divide. What's x? Okay, so this is a bad example. I got a negative value and I shouldn't have. I just made this up off the top of my head and didn't have a chance to work it out. So if we plug a negative 8 back in, and we want to plug it into DE, negative 8 minus 7 would be a negative 15, right? It doesn't make sense to have negative values. Okay, so I need to fix this problem. Okay, but same idea. You'll have some positive values, things that actually make sense. Okay, so far so good? Questions on this one? Okay, so whatever we get for x, we've got to plug back in. And in this case, I picked a bad problem, or a bad answer. That doesn't make sense in geometry. It would make sense in algebra, but not in geometry, because we can't have a negative side length. Okay? All right, so here we go with the next one. So, trusses use the mid-segment theorem. Anybody know what a truss is? What's a truss? Absolutely. Okay, it's the support structure for a roof. So you put your plywood on top, you'll have multiple trusses across the way. Plywood on top, then your shingles on top, or whatever material you're using for your roof. Okay? So this is one example of a truss. And in this example, they say, hey, guess what? We use triangles to strengthen roof trusses. They're naturally, arches and triangles are natural building materials because they help make things strong. Okay? In this diagram, UV and VW segments are mid-segments of this triangle. Okay? So it looks really busy, but if you focus on just the part that you need to, you'll be fine. So if they tell us that we want to find the distance between U and V and the distance between R and S, first of all, let's highlight this triangle that we're working with. Here's our big triangle. And they said that UV, segment UV, is a mid-segment. Okay? So this one is a mid-segment of this one, of the triangle, but parallel to that base, right? So what would the distance between U and V be? Who knows the answer? Find somebody else. What do you think, Olivia? Okay, if this is a mid-segment, and this is the one that it's parallel to, how long do you think UV will be? So we have a measurement of 90 down here, right? Is it equal to 90? Looks kind of small to be 90, doesn't it? So what's it going to be? Austin. It's going to be 45. How'd you get 45? Half of the side of the triangle, okay? So find the one that it's parallel to, and if they give you a measure, then we're going to divide it by 2, okay? So UV, the distance between U and V, is 45. Okay? Now we're going to do the same thing again, okay? This time, they told us that VW is a mid-segment. So VW is going to be parallel to SR. And they told us that VW is 57 inches. So how are we going to figure out the distance between S and R? Okay, Jared. We multiply it by 2. So we're going to take 57 times 2, and we get 114. Okay, so the math is not hard here. And the vocabulary is not horrible, right? Because mid-segment makes sense that it would be a segment that connects midpoints, right? So after all the vocabulary we've had the first part of the chapter, this will be a little easier. That make sense? All right, so quick notes today, quick assignment. You should finish in class.